In this video, we're going to find the derivatives of a given function. So let's start with our first exercise. So in our first exercise, we have our first problem. We have the derivative of 2x plus 7. So how can we find the derivative of 2x plus 7? First and foremost, let's apply one rule of differentiation, which is sum and differentiation. Right, let me just put diff in short for difference. So basically, if you have a given uh, at least two functions where they are separated by addition or subtraction operation, just like this, the derivative of f of x plus minus g of x. So here, what we're going to do is we're going to distribute this operator to each of the given functions, right? So the result here, you will have the derivative of f of x plus minus the derivative of g of x. So we can apply that in our problem. We have the derivative of 2x plus 7. So just simply distribute this operator to each of the terms here. So the result would be the derivative of 2x plus the derivative of 7. Okay. So now, in these two terms, we're going to apply two rules of differentiation. Two rules of differentiation. So let me just erase this one first. So the first rule that we're going to apply is for our first term, which is 2x. So we're going to apply a rule that talks about a term that has a constant and a variable, in which that the variable has an exponent of 1 only. Basically, you will only apply this rule if and only if you have terms that has 1 a constant and 2 a variable that has no visible exponents. So what will be the derivative of that? Like if we have a constant and a variable. So the answer for that is basically a constant itself. So in this problem, we have the derivative of 2x. So the derivative of 2x is just simply 2. Okay? We apply this rule to the first term. Okay? Now, how about for the 7? 7 is a constant term. So we will apply constant rule of differentiation, where if you're going to get the derivative of a constant term, the answer here would be 0. Hence, the derivative of 7 is 0 because it is a constant term. So to simplify, you will have 2 as your final answer. So the derivative of 2x plus 7 is simply 2. Okay, so that's our first problem. So let's proceed to the next problem. We have this one. The derivative of 3x squared. Let me take a look. 3x squared plus 4x plus 1. Okay, plus 4x plus 1. Oh, wait, let me just fix this one. Yeah, 4x plus 1. Okay. So all terms are separated by addition operation. So we can apply sum and difference rule of differentiation here. So as a result, we will have like this. The derivative of 3x squared plus the derivative of 4x plus the derivative of 1. Okay? So the rule that I'm going to apply for our first term is constant multiple rule of differentiation. Basically, what if there's a coefficient to a given function? Just like this, we have a coefficient of 3, and here we have a given algebraic function. So we're going to use constant multiple rule of differentiation for that. So if we're asked to get the derivative of a given function where there is a constant given outside that acts as a coefficient, what happens is that the constant is not differentiated, but the derivative, but the function is only going to be differentiated. So basically, if you have a constant in a given function and you're asked to get the derivative, just simply bring out the constant and then just focus getting the derivative of the function. All right? So let me just shrink this into small size so that I can have the space here. So here in this case, since we have a constant of 3, so we can just bring it out. So we will have 3 times the derivative of x squared. Okay? So you can also do the same thing here for the derivative of 4x. You have a constant and you have a algebraic function which is your x. However, I'm not going to do that because there's actually a rule that we can get the derivative for this one, which is this. But uh later I'll explain. All right? So let me just copy the other terms. So 4x plus the derivative of 1. Okay? So in our first term, we have a variable that has an exponent. So if it has an exponent, we're going to apply power rule of differentiation. So let's just say we're asked to get the derivative of a variable where exponent is given. So if you're going to get the derivative, the result would be n times x raised to n minus 1. That will be the result. So we can apply that here in our first term, which is x squared. So all we need to do is simply bring down the exponent given here, which is 2. Then copy the function here, which is x squared. Then the exponent above, you're going to subtract it by 1. All right? So it's just like you brought down the exponent of 2, and then the exponent here above, you're just going to subtract it by 1. So this is the result. Okay? Plus, the derivative of 4x, we're just going to just use this one. Okay? Where the derivative of a term that has a constant and a variable whose exponent is not visible is just a constant itself. So the derivative of 4x is just simply as 4. Right? Then, then, last but not the least, the derivative of 1. 1 is a constant term. So the derivative of a constant term is 0. So you will have plus 0. Now let's combine everything. 3 times 2 is 6. X raised to 2 minus 1. So 2 minus 1 is simply 1. Or we can just leave it as 6x. Because anything raised to 1 is just simply as the variable itself. Like for example, t raised to 1 is just the same as t. So 2 is just the same as 2 raised to 1. You get me? So we can just leave it as 6x. Then we have plus 4. All right? Then we can simplify this one further because you see 6x and 4 are both divisible by 2. So we can factor out 2 in this expression. So we will have 2 times quantity 3x plus 2. And this is the final, wait, this is the simplified final answer. 2 times quantity 3x plus 2. That's it. All right. By the way, for this term, like 4x, basically for the term that has a constant and a variable that has no visible exponent, you can use power rule of differentiation. All right. For 2x and 4x, you can use power rule of differentiation. Right? It's still valid. Let me demonstrate it to you. Right? We have the derivative of 4x, right? And then we're going to apply constant multiple rule. So we have a constant of 4. We can just simply bring it out. So you have 4 times a derivative of x. Now, as I said earlier, remember, right? T raised to 1 is just the same as t. So basically, any variable that it doesn't have a visible exponent, it actually has an exponent. Where if you see x, this is just the same as x raised to 1. So that means we can apply power rule of differentiation. So in applying power rule of differentiation is just simple. All you need to do is, again, bring down the exponent, okay, this exponent. So you have 1. Then copy the given function here. So you have x raised to 1. Then the exponent above, you're going to subtract it by 1. So minus 1. So to uh, get the answer, just simply multiply or combine. So you have 4 x raised to 0. And recall that anything raised to 0 except 0 is 1. Okay? Anything raised to 0 except where your what do you call this one? Where your a is 0 is equal to 1. Okay? So that means this is just the same as 4 times 1. So you will have 4, right? Hence, you have this one as your answer. And you can also do that the same thing here for the 2x. Okay? So yes, that's basically it. But for simplicity, like to go direct to the point, just use this one. This one. Just use this one. This is much better. All right? Instead of just using power rule. Okay? So now we're going to proceed to the last problem. So we have the derivative. Mhm. We have the derivative of x cubed minus 6x squared, then plus 1 all over x. Okay. So first and foremost, we're going to apply sum and difference rule of differentiation because all terms are separated by either addition or subtraction operation. So distribute the operator to each of the terms here. So the result is we will have the derivative of x cubed minus the derivative of 6x squared minus the derivative, plus the derivative of 1 all over x. Mhm. So yeah, that's it. So now, we have 6x squared here as our second term, right? So we have a constant that acts as a coefficient to x squared. So we're going to apply constant multiple rule of differentiation. Again, what's constant multiple rule of differentiation? Basically, if you have a constant here and then you have a function together like this, just simply bring out the constants and focus differentiating the function. So hence, let me just rewrite the other terms first. So hence, we will have 6 times the derivative of x squared. All right? Then for this case, you see, it seems like it's impossible for us to differentiate this, because we have a variable inside. Below the fraction. So what we can do here, we can actually bring it up, you know. According uh to a law of exponent, which is the reciprocal law of exponent, where if you have x raised to n, you can just have 1 all over x raised to negative n. All right? So, point being, if you're going to put x up or down, the sign of the exponents will change. Like, for example, 1 all over, let's just say x cubed. But you want x cubed upward, like you don't want it to put it below, you want to put it on top. We can do that. So we have x, but the sign of the exponent will be changed. So this would be negative 3. All right? So another example, we have x squared, but we want to bring it down. So we will have 1 all over x raised to negative 2. All right. So basically, if you're going to put it up, change the sign. So here we have x, right? So here, this is just the same as x raised to 1. So if you're going to bring it up, you will have the derivative of x raised to negative 1. You see, all of the terms here, they have a visible exponent. So we're going to use power rule of differentiation. Right? Let me just rewrite it here. So n. No. X raised to n. Much better. So again, in power rule of differentiation, we will have n times x raised to n minus 1. So basically, all right, let's start first with the x cube. We're going to bring down 3, copy the function x cube. Then the exponent above, you're going to subtract it by 1. We will do the same thing to the other terms as well. So 6 times the derivative of x squared. So bring down the 2. Then copy the function x squared. Then subtract the exponent by 1. So you have 2 minus 1. Then lastly, we will do the same thing here for x raised to negative 1. So bring down negative 1. All right. Then copy the function x raised to negative 1. Then subtract the exponent by 1. So you have minus 1. So let's combine. So 3x raised to 3 minus 1, that's 3x squared. Negative 6 times 2, that would be 12. Then 2 minus x raised to 2 minus 1 is just simply as x. Then here we have positive, negative. So positive times negative, you will get negative. Then here we have x raised to negative 1 minus 1. So you have x raised to negative 2 as a result, right? So we can leave this as our final answer, or we can fix this one if you don't want to have a negative sign of your exponent. So if you're going to change the sign of the exponent, we will apply reciprocal law of exponent. All right. So here we have x raised to negative 2. So if you wish to change the sign of the exponent, just bring it down. All right. So the result would be minus 1 all over x squared. So we can leave this as our final answer. All right. So it's up to you if you're going to make them as a whole fraction, since one of the terms here is a fraction, or we can leave it that way. By the way, this is also correct. Okay, this is also correct, right? But for me, I think this is much better, right? This one, the answer that I what's the right shape for this one? That I rectangle to it. But yeah, that's the answer here. And that is all for our first part. So heads up for the second part for this exercise. See you.